input, there will be an error detector which will generate an error signal. Okay, when feedback is given towards the input, an error detector which will generate an error signal. This error signal is given to the controller. Okay, this controller, based on the error signal and the input that is given to it. Okay, this controller will generate an actuating signal which is input to the plant. Okay, and this plant will this plant generate a desired output. Okay, so whenever a feedback is given, there may be error signal or there may not be error signal. Error signal is generated only when there is any disturbance in the system. If there is no disturbance in the system, then error signal will be equal to 0. The difference of the input and the error signal is given to the controller. Okay, in error signal is given to the controller. If error signal is 0, then only input will be the controller. Input minus error signal 0 means input minus 0 is input. That's all. Okay. No error, no problem. Output is obtained. If there is any error, that error will be cancelled from the input and remain will be given to the controller. Okay. So usually this feedback system is widely used in amplifier circuits, oscillators, process control systems, as well as other types of electronic circuits. Okay. So feedback majorly affects the performance characteristics of the control system, such as stability of the system, overall gain of the system, disturbance, and the sensitivity. These are all the factors which are affected by the feedback. Okay, factors affected by feedback or feedback affecting the factors are stability, overall gain, disturbance, and sensitivity. We are going to discuss detail about the stability, overall gain, and disturbance and sensitivity of the system. My mobile is falling down. Now it is better. Okay. Now let us see what is the need of the feedback in electronic. Okay, the circuit characteristics of the system that we consider. Okay, the circuit characteristics of the system are the overall gain of the system and the response. Overall gain is the rate of the output to the input. Is nothing but our overall gain. Okay, response means output of the system. Okay, the overall gain of the system and the response of the system should be controlled. It should be controlled. It should be precisely controlled. Okay, so the circuit characteristics must be precisely controlled. Okay, they should be condition. Means they should be given input, bad output should be, overall gain should be good. Good overall gain we must get. Okay, for the given system, for the given input to the system. Okay, circuit characteristics are nothing but gain and the response of the system, which should be controlled. These gain and response, they are independent of the supply voltage and temperature variation whenever because of the feedback. Okay, so feedback, whenever feedback is given, the gain and the response may become independent of the supply voltage or the temperature variation. Okay, so signal distortion due to non-linear nature of the components. For example, if I consider a circuit, okay, it will have linear characteristics. Okay, so and if I consider a diode, if diode is there in my circuit or in my system, we know diode has non-linear characteristics. So whenever a component in a system has non-linear characteristics such as diode, it may distort the signal. Okay, it may distort the signal. So such distortions will be reduced because of the feedback connection. Okay, if non-linear nature components are there in the system, then signal distortion can be reduced by giving feedback to the system. Okay, the frequency response, gain, and bandwidth can be controlled within the limits by giving the feedback. Okay. Next, Amma, the feedback can be mainly categorized into two types: positive feedback and the negative feedback. Positive feedback system is defined as the positive loop gain around a closed loop of cause and effect. Okay, here you can, if RS is input to the system, CS is the output, G of S is controller and processor. Together we have represented in a block. This is a block. Okay, the controller and the process are represented by this GS, and the output is fed back to the input by a feedback element H of S. Okay, here feedback element is H of S. Okay, and the controller and process or plant, you can say, they are represented by GS. Okay, I hope everyone is maintaining notes and you are noting it down. Okay, if you simply listen, you can't remember. Okay, that you must know as an engineering student. Okay, so it is given to G of S. Okay, and C of S is up. Of course, since feedback is there from output to input, so whatever output is generated, that is fed back to the input, okay, with a positive feedback signal. The feedback signal that is given is here is positive feedback signal. Okay, so I can find by sort of arrangement. So in simple, what I can say about the positive feedback system is that feedback is positive to a positive feedback system. Okay, this is a positive, you can see. Okay, so from this sort of arrangement, we can determine the transfer function of a system. What is the transfer function? After feedback, after this topic, we'll explain. The next topic is our transfer function. What is transfer function? How it is defined? What is its definition? We'll explain it to you later on. Okay. Now, so if I want to know the transfer function of this system, it is nothing but the ratio of C of S by R of S. Ratio of C of S by R of S will give me the transfer function of this system. Okay, so C of S by R of S will be equal to G of S by 1 minus G of S into, okay, G of S into plus H of S. Okay, H of S is positive here. Okay, so I will get G of S equal to C of S by R of S, G of S by 1 minus G of S into plus H S, plus into minus, minus. So I will get G of S by 1 minus G of S, H of S. Okay, so actually if you see this diagram in this circuit, you can see this. What we can see is H of S is added with the R of S at this summing point. This is a summing point. Okay, this is a summing point. So when feedback is given to the system, R of S as H of S is given to this controller and process. Of course, first controller will come, later on process will come. In general, we have replaced it by some GSS. So overall input is increasing here. Okay, in the positive feedback system, what is happening? Because of positive feedback, the input to this controller and process is increasing. When input increases, what happens to the output? Output increase. Okay. What is the gain or the transfer function? Put by input is gain. Output increases and C of S by R of S increase. Okay, C of S magnitude, numerator magnitude increases means automatically the output is increasing, gain also increasing. So overall gain of the system is increasing beyond what input for given input on the corresponding output. But here because of positive feedback, additional control is taking it as an additional input. So the overall response or the output is increasing. Okay, which is not expected. So system becomes unstable or instable, you can say. Okay, so system becomes unstable because of the increase in the gain. If you want, you can go through here. So positive feedback is in phase the input. That is, it makes input larger. This causes system stable due to increase in the system. That is, overall gain with feedback applied will be greater than gain without feedback. Without feedback, what is happening? If feedback is not there, for the given input R of S, I am getting C of S. Okay, I am taking attendance. 63. Okay. Okay. For the given input R of S, I am getting output C of S. Okay. So when feedback is not there, when feedback is given, R of S is adding it with the H of S. Both are given as inputs to the system. So overall gain is increasing, which makes system unstable. Okay, so So because of this positive feedback, what is happening? System is become unstable. We don't want any unstable system. We want a stable system. Okay. So we call this G of S into H of S as loop gain. Okay. G of S into H of S can be called as loop gain. So if G of S into H of S is greater than 1, okay, if it is greater than 1, then there will be a typical exponential growth, increasing oscillations or divergence from the equilibrium of the output. So output will have an exponential growth, okay, increasing that causes oscillation and divergence from the equilibrium. Means the output is completely deviated from the actual output value. Okay, so a positive feedback may be controlled by signals in the system being filtered, damped or limited, or it can be cancelled or reduced by adding negative feedback. Okay, so by using filters or damping elements, okay, or by using some signal limiting elements, or by giving a negative feedback, we can reduce the overall gain of the systems to make the system stable. Okay, so better so now you might have understood before going to the negative feedback system itself. It is understood from this topic that if we use a positive feedback system, the overall system gain increases, which makes system unstable. So better to go for negative feedback system. Let us see what is meant by this negative feedback system. So here you can see a negative feedback system. Feedback is negative here. So RS minus HFS will be given as input to this controller and process. Of course, directly this is not given to the process, it is given to the controller. Okay, so RS minus HFS means whatever for the given input, whatever output is obtained, that is fed back here, and the difference of these two means actually when feedback is given, it should be the whatever input that is given here from HFS should be 0. If no error, it will be 0. If there is error, there will be some difference between RFS and HFS that is given to the controller. So the input that is given to the controller is using here. In the case of negative feedback system, the input given to the controller is reducing. Okay, so overall input that is given to the controller is reducing. So the overall gain or the response will not increase. So if you want to see the transfer function of this system, transfer function T of S is equal to output by input, that is C of S by R of S is equal to G of S by 1 minus G of S into minus H of S. H of S is minus here. 1 minus G of S into minus H of S. Minus H of S into minus, you will get plus G plus. Okay, so G of S by 1 plus G of S, H of S. Okay, if the system output changes for any reason, the negative feedback put in such a way that we are counteract change in the system. Okay. So when negative input is given, negative feedback is given, not input. Negative feedback is given to the system. What is happening? The overall input is given to the controller will be reduced. So you will get a controlled output. Okay. So the negative feedback reduces the overall gain of the system. Okay. Overall gain of the system. Degree of reduction being related to the system, open loop gain. Okay. The degree of reduction related to the system, open loop gain. Open loop gain means what? G of S. Open loop gain is G of S into H of S. Okay. G of S into H of S is known as the open loop gain. Okay. In brief, if you wanted to differentiate between positive feedback system and negative feedback system, I will start. In the positive feedback system, feedback is positive. In negative feedback, feedback is negative. In the positive feedback system, the overall input increases. Input is in phase with the feedback. In the negative feedback system, input is not in phase with the feedback, therefore overall input reduces. In the case of positive feedback, since the overall input has increased, what is happening is the overall gain increases and system becomes unstable. In the case of negative feedback system, overall input is reduced. Okay. because of the error signal, because of the cancellation of the input with the error signal or error signal cancellation with the input. Okay, the difference of input and the error signal is given and to the controller, so overall gain is reduced. Okay, and system is a stable system. Let us see the effect of feedback. Okay, on overall gain, sensitivity, stability, and noise. How the feedback affects on the overall gain of the system. Overall gain is nothing but our, we can say, transfer function, Laplace transform of C of S by R of S. Okay, so we can even differentiate between the gain and the transfer function also. It is not required now, that's why I'm not going to it. Okay, wait. Okay, 1 minute. Some changes have occurred here in my in my PPT. Okay, so it was already there. Okay, it's okay. I can explain without any disturbance. Okay, Amma, effect of feedback on overall gain. From the above equation, what we can say? The overall gain means here let us consider T of S. T of S value depends on addition of G of S and 1 plus G of S into H of S. Okay, from this equation, what we can see is the overall gain is transfer function T of S. It depends on the value of G of S and 1 plus G of S H of S. Okay, so if 1 plus G of S decreases, then G of S increases. Okay, if 1 plus G of S increases, then G of S decreases. Okay, if the denominator increases or the T of S, not G of S in general, if the denominator increases, then T of S value will reduce. If denominator decreases, T of S value will increase. Okay, because of the division with respect to G of S. Okay, so the T of S value will vary with respect to 1 plus G of S into H of S. As 1 plus G of S H of S vary, okay, if it increases, G of S will not increase, sorry, T of S will decrease, it reduces, G of S has to do nothing, but of course it has to, by dividing these two terms, this term will, it depends, okay, it depends. Okay, what I have explained, I have written here in terms of these equations. Okay, so whenever I try to convert this justification mode, all sort of changes occur. Okay, that's what's happening here. Okay, so in case G of S in H of S value is negative, okay, because of the gain of feedback path is negative. In case, okay, if the value of, oh, sorry. Okay, so sorry, I might have started from here. Okay, if the value 1 plus G of S, H of S is less than 1, then the overall gain increases. Okay, then the overall gain will increase, which I have already told you in terms of less than or if it decreases or increases. Okay, so as its value varies, automatically the gain is also varying. Okay, the gain also varies as the value of 1 plus G of S, H of S varies. Okay. Okay, there is a note, you can go through it. Okay, let us see the effect of feedback on sensitivity. Okay, so here I am considering G of S term, open loop gain path. Okay, and I am also considering the overall gain. Overall gain is T of S. And the open loop gain is, I am considering here as G of S is the open loop gain. Feedback path is 1. Let me consider H of S is 1. Okay, H of S feedback is 1. Okay, so only G of S term will be left over. Okay, so I want to see how sensitive that system is. Okay, because of feedback. So I am considering a negative feedback system. Okay, so sensitivity is given by percentage change in the overall gain by percentage change in the open loop gain. Okay, sensitivity of a system is defined as percentage change in the overall gain by percentage change in the open loop gain. Okay, what is this percentage change? You can see change in T by T, change in or differential, partial differential, we can say. Okay, so dou change in general, we can say change in T. This is the dou T means change in T by T, dou G means change G by T. Okay, okay. So change in T is incremental change in G due to incremental change in G. That's all. Yes, isn't it? If G varies, automatically T will vary. Okay. If G increases, T increases. They are directly proportional. Okay. So it depends. So value how it varies, it depends. So this whole equation can be rewritten like this. Okay. It can be rewritten like this. Okay. And if you simplify further, okay, simplify further, you will get this based on this equation. Based on this equation, if you substitute T of S is nothing but G of S by 1 plus G of S at first. Okay, if you substitute that here, okay, so instead of T, what I can write? G of S here is, so I can write G by 1 plus G into H. Okay, so G by 1 plus G into H. So, wait, I can write with a pen. I can, so I have taken a text. Okay, so G by, sorry, text. Okay, G by, okay, I'm starting a bracket, G divided by 1 plus G into H. Okay, so why I have written only G into H? The reason it instead of, I didn't consider here G of S. I might written here G of S. I didn't write here. Okay. So now, so G by G into 1 plus G into H. Okay. So this can be written as G into G into G into 1 plus GH by divided by G. You can write like this. So G will cancel. And then you can write like this. Okay. You can rewrite like this. Okay. So simply by substituting transaction equation here, you will get sensitivity is the local of 1 GFS. Okay. So G of S equation, if there is any equation, substitute that equation also. We don't have any equation. Actually, in general, based on the analysis, the engineers have found that it will be reciprocal of 1 by G of S, H of S. Yes. Okay, sensitivity. So, as this open loop gain G of S, H of S value, the denominator value will vary. Okay, as the denominator increases, sensitivity will decrease. As the denominator decreases, sensitivity will increase. So in general, if we talk, sensitivity of a system should be as low as possible for the changes that occur. For any sort of disturbance, system should not be more sensitive. So if you want, you can see here the sensitivity of the overall gain of the closed loop control system is a reciprocal of this. Therefore, sensitivity may increase or less depending on what. Okay, I have already said. If the value of 1 plus G of S, H of S is less than 1, then sensitivity will increase. Okay. In case G of S, H of S value because of the gain of the feedback path is negative. In this case, okay. If it is less than 1, this value will be negative. Okay. So if it is greater than 1, G of S, H of S will be positive. Okay. If it is a good control system, it should be should be insensitive. Okay. It should not vary for the unnecessary disturbances. It should not. Actually, what happens is, if any disturbance occur, what happens is, the system will take it as another input. Disturbance is also considered as another input, and considering it also as input, it will produce some distorted output. Okay, so in order to, so if the system is insensitive to the disturbances, then controlled output will be obtained. I will read this line, you just listen carefully. A good control system should always be very insensitive to the parameter variations, and it should be sensitive to commands. Commands means whatever input that we give, hence feedback can increase or decrease the sensitivity of the system. Okay, depending on the requirement, the sensitivity should be varied. Now, some I have written some notes so that it will, you can go through it. It's not related to what my discussion. So simply, in order to improve your knowledge, I have given these notes and all. Okay. Next, effect of feedback on stability, Amma. Okay, a system should be stable. That's what in general, before even discussing this topic, in your mind, first word that comes is the system should be stable. A system is stable means what? Output is a controlled output. If for the given output, given input, sorry, if for the given input, if the output is a controlled output, then we can call that system as a stable system. Okay. Otherwise, it is called as an unstable system. So let us consider a negative feedback system. The transfer function of a negative feedback system is what? G of s by 1 plus G of s h of s. In this equation, if the denominator value is 0, okay, when will the denominator will become 0? If this whole term is minus 1. 1 minus 1, 0. Okay, then the output control system will be infinity. Okay, the denominator is 0 here, the output will be infinity. So, the control system becomes unstable. Okay. Therefore, we have to properly choose the feedback in order to make the control system stable. Okay. So, denominator should never be 0 to avoid the system to become unstable system. Okay. This is about stability. Effect of feedback on noise. Okay. So let us see how the noise affects the feedback. Sorry. Okay. How the feedback. How the feedback affects the noise. Let's see. Okay. So we know two types of control systems. Those are open loop control system and closed loop control system. Okay. So in the case of open loop, let us consider an example of open loop control system. Okay. So here I am giving input to the block. Okay, GA is nothing but our transfer function. We can call it as a transfer function. Usually, transfer functions are written in the blocks. Okay, so it is the ratio of output by input, of course. Okay, so this is given as input to GB, and another noise signal is there. N of S is the noise signal, which is also given as input to the GB. Okay, so for simplification, let us assume R of S is 0. If R of S is 0, then N of S is the input. Okay, N of S is R of S. Okay, whatever output is generated from GA will be added with N of S, of course. Suppose R of S is 0, then nothing will be added with the N of S. N of input, C of S is the output. So then transfer function is what? C of S by N of S will be equal to GB. C of S by N of S will be equal to 0 GB if R of S is equal to 0. In the case of open loop control system, consider it as equation number 1. Now let us go for a closed loop control system. In this case also, in order to discuss about the noise signal, let us consider the input signal R of S is equal to 0. If R of S is 0, okay, if R of S is 0, nothing is there, H is directly connected to GA. H is directly connected to GA. So, transfer function is what? C of S by N is the transfer function. Because N of S is acting as the input, C of S is acting as output. Output by input is nothing but our transfer function. So, C of S by N of S will act as input. Okay, sorry. C of S by N of S will be our transfer function. So, C of S by N of S is equal to GB by feedback element as, what does the feedback element have? Two elements here. Feedback has two elements, H and GA. Okay, the starting point is not there now. Okay, I have assumed R of S is 0. So, G by 1 plus negative feedback, 1 plus H into GA into GB. Okay, so see, GB by 1 plus GA, GB, H. Okay. So it's a negative feedback system I am considering here. So if you see here, You consider this as a second equation. If you compare this second equation with the first equation, here the transfer function of P of S. What is P of S? It is the output, isn't it? Output is directly depending on GP value. Output is directly depending on the GP value. Means if GP varies, then output will also vary. As in case of closed loop system, C of S is depending on GB by 1 plus GA GBH. Okay. So if denominator varies, automatically C of S will vary. Okay. It is the ratio of GB by transfer function is the ratio of GB by 1 plus GA GBH. Okay. So since there is a denominator element, even though noise is the input, the overall gain is reduced here. Okay. The overall gain, transfer function is nothing but G of S, C of S by N of S is the transfer function, overall gain. The overall gain is reduced here, whereas in the case of open loop system, overall gain is not reduced, it is constant, some GB value. Whereas in the closed loop system, some GB by some denominator. Okay, so GB by some denominator. Okay. So you can go through here in the closed loop control system. The gain due to the noise signal is decreased by a factor of decreased by a factor of this, provided that the term is greater than 1. Okay, provided that this 1 plus GAGB is greater than 1. So in the case of closed loop system, what we can say, the noise can be reduced when compared to open loop system. Okay, so I can go for the transfer function. Small topic, 5 more minutes. I will go for the transfer function. Next week, come on. Next topic is transfer function. So transfer function is the relationship between the output signal and the input signal. Okay, for all possible input values. Okay, so transfer function is usually represented by a block. Okay, transfer function is usually represented by a block, and it gives the relationship between the output and the input, whereas the output and the input should be converted into Laplace forms. Okay, so in other words, what I can say is transfer function is the ratio of Laplace transformation of the output by the Laplace transformation of the input. Okay, so okay, sorry. So if you want the proper definition, you can go through this. The transfer function of a control system is defined as the ratio of Laplace transformation of the output variable to the Laplace transformation of the input variable, assuming all initial conditions okay to be 0. All initial conditions are assumed to be 0. Okay, so basic block diagram representation of the transfer function with respect to input and output is this. Okay, where R of S is what? Laplace transformation of the R of t. C of S is the Laplace here some. Okay, C of S is the Laplace transformation of the C of t, where C of t is the output in time domain form. R of t is the input in the time domain form. Okay, actually inputs will be given in time domain only, output will also obtain in time domain, but whenever we discuss in terms of transfer function, it is the Laplace transformation of output by Laplace transformation of the input is the transfer function. Okay, so if you have few more minutes, I will conclude these examples also. Okay, so I have considered an RC circuit here. Okay, so I have considered a simple series circuit, R and C series circuit. I am giving input V of t as input. Okay, because of this V of t, some current is flowing in the circuit, that is I of t. So what is the input here? V of t is the input. What, because of input, what is happening here? What is the output here? Output, I of t is the output. Okay, what are all the components here? R and C are the components. Okay, R and C are the components of the circuit. Okay, input is V of t, output is I of t. Okay, so I want to determine the transfer function. What is transfer function? It is the ratio of Laplace transformation of the output by Laplace transformation of the input. Means I of t is to be replaced by its Laplace transform I of s. V of t is to be replaced by its Laplace transformation, that is V of s. You have already learned Laplace transformation in your circuit subject. Your staff might have taught you. Okay. So for this circuit in time is in time domain form. For this circuit, you can write an equation, isn't it? With respect input with respect to by this is nothing but our Ohm's law. Okay, this is nothing but our Ohm's law. According to Ohm's law. Okay, so you can write as V of t is what? It better you people note it down. Okay, better to note it down in your notebook. All these problems, whatever I discuss, within few minutes I will conclude. Okay, now within 5 minutes it will be over. Don't worry. Okay, so V of t is equal to R into I of t, R into I of t plus 1 by C into integral of I of t dt. This you already know. Okay, this equation you already know. Now converting this time domain into Laplace form. Laplace of V of t is V of s, R is constant, I of t is I of s. Okay, here for integral of 1 by C integral of I of t dt is, sorry, is 1 by Cs into I of s, or 1 by C into I of s by s. Okay, so in this case you can see I of s is common, you just remove it. Okay, so I of s, V of s, R plus 1 by C of s you will get. So okay, so what is transformation? Output by input. Output is what? I of s, input is V of s. I of s by V of s, we just send this to the left side, you will get, you will get this equation. I'm sorry, this is input by output, isn't it? This is wrong, huh? I'm cutting it. Okay, I'm cutting it because V of s is input, applied voltage is input, I of s is the output. Okay, so I think I wrote that equation. So simply this I have actually I wrote these equations in Paint and I pasted here because because if there is any changes in the settings, the whole terms are varying. So I of s by V of s, send this term to 1 by R plus 1 by C into S. You will get the transfer function. Okay. Next term, for this is a parallel circuit. Okay. This is a parallel circuit. Input is E input, E output is E output. Okay. So you can write the equations. Okay. And so this is the input equation. Okay, input equation is in this loop. In this loop, R plus I of t 1 by C integral I of t dt. Okay, so E output is across this capacitor. E output is across this capacitor. So E output is 1 by C integral I of t dt. Okay, so Laplace transform of E input is E input s. Laplace transform of E output of t is E output s. Laplace transform I of t is I of s. Laplace transform integral of I of t dt is I of s plus by s plus, okay, integral of I of 0 dt. Initially capacitor, no current flows through the capacitor, therefore integral of I of 0 dt is 0. So Laplace transform of integral of I of t dt will be I of s of by s plus 0. So you will get I of s by s plus 0, you will get I of s by s. Now let us go to the input equation. This is our input equation. So convert all these terms in Laplace transform. If you convert that in Laplace transform, you will get E input, you will get E input of s is equal to R of I of s plus same equation which we already wrote for the previous problem. Okay, you just take out I of s common. Okay, you will get this equation. E output you will get I of s by C of s. Okay, so this is what it is. Now here in this case, input is E input, output is E output. So E output by E input. In this case, I have written correctly. Okay, previous case there was a mistake. Okay, instead of output, I wrote input. So just take the ratio of these two, simplify it, you will get this equation. Okay, if anybody wants to ask anything, you just ask. Amma, if you have any doubts, ask. I'm taking this snapshot. So earlier there were more than 63. Now strength has reduced on 60 members. Anybody